Okay, so let me do this first one here. Find all values for which f of x is greater than g of x. All right, so let's work on that one. Now, I made it a greater than or equal to simply because it makes it a little more interesting of a problem and something you're going to have to be aware of when you work on the exam. If I want f of x to be greater than g of x, that's really saying that I want 1 over x to be greater than or equal to 1 over x minus 1. Now the way you solve rational inequalities is you first get things on one side. So I'll move that over here. We're looking good. But now I've also got to write this using one rational expression. So I get common denominators here. Multiply by x over x and x minus 1 over x minus 1. Combine like terms in the numerator and I get this expression. It's this expression that I wanted to work my way to. This one right here where I've got 0 on one side and the other side is written with one rational term. Once I get here, I need to find where the numerator equals 0 and where the denominator equals 0. Well, the numerator doesn't equal 0 at all, so there's no solution there. You've got x times x minus 1 equals 0 in the denominator. Where does the denominator equal 0? 0 and 1. So you put those on the number line and you number your solution, or you write down your intervals. Negative infinity to 0, 0 to 1, and 1 to infinity. Now I'm not going to take the time to actually show this, but you would go through and test points. So you need to test points that are kind of in between all this stuff. What would be some good test points for us? Negative 1, 1/2, and 2. Sure. You don't have to do anything really fancy. You can't use 1 as a test point though, right? Because that's one of the endpoints. I'm pretty sure that this is going to calculate out to negative, positive, negative. Negative, positive, negative. Which interval or intervals do I want? Do I want the negative or the positive ones?
Positive.
Positive ones. So I want the middle interval. So my solution is going to be 0, 1. Now because this is a greater than or equal to, you want to be careful as to whether or not you're going to include the endpoints. So am I going to include either?
Don't know because it's in the denominator. Wait, hang on a second.
Well, we can't let x equal 0 because that would put it 0 in the denominator. So I'll put a parenthesis around there. And we can't let x equal 1. So both of them get a parenthesis. Yay. All right. Let's keep going. Next one. Let's try and find the domain of this expression. Now this is actually kind of a clever way of asking somewhat the same problem that we just had. F of x is the square root of, let me write it as negative x squared plus x plus 56. If I want to find the domain, what's my big concern for a function like this? What would I be worried about? Yes?
You can't have it be negative because taking a negative value of the square root is going to be an imaginary value.
Yeah, I want to make sure that this is greater than or equal to 0. So we got 0 on one side. Let's actually find out where this actually equals 0. And I can do that by factoring. If I factor out the negative here, that becomes negative of x squared minus x minus 56. And that's going to factor into x minus 8 times x plus 7. So where is it actually going to equal 0? Well, it's going to equal 0 at 8 and negative 7. So negative 7 and 8. Now, let's go back here. I'm going to work with this expression. This has got 0 on one side. I want to know where this is positive. If you're bothered by that negative sign, you can divide both sides by a negative. But when you divide by a negative, what happens to the direction of the inequality? It switches. So you could look at x minus 8 times x plus 7 is less than or equal to 0. Either way, it's going to solve okay. But sticking with this one's going to turn out to be, let's see. All right, you can do your test points. I was trying to kind of hurry this one up, so I think it's going to be negative, positive, negative. And we want the positive intervals. So that would be between -7 and 8. How come I can use the endpoints here and I didn't in the last one?
There's no denominator to divide by.
Yeah, there's no denominator. You can have x equals 0 underneath the radical. You just can't have anything less than or equal to 0. So that would be your domain. Okay on that one? All right. Let's keep going. Let's try this one here. This is a good one because there's a couple tricks in this one that we've got to pay attention to. I think I remember trying to call your attention to it when we did one like this in class. Let's do another one. So this is an exponential equation. 3 to the 7x plus 1 equals 7 to the x minus 3. Now it's not perfect, but we can try and make our life a little bit easier by taking, log of, one base or another that might help out. You got to take log of the same base for both sides. But just to make my life a little bit easier, I'm going to take log base 3 here. So what good is that going to do me? Log base 3 of 3 to the 7x plus 1 equals log base 3 of 7 to the x minus 3. How does that help me?
It cancels out the log base 33, so you just get 7x plus 1 on one side.
Yeah, on the left-hand side, I get 7x plus 1. On the right-hand side, this doesn't cancel into anything special. But something nice does happen.
X plus 3 comes out.
X plus 3, perfect. Thank you, Julian. X plus 3 comes out, or x minus 3, I should say. Like that. Now, here's the first of a couple tricks. So, if you're keeping track as to why, right here, let me do it like this. Right here, I'm going to distribute the log so that eventually I can move the terms in x around. Distribute the log to free up the x terms. So that's going to give me 7x plus 1 equals x log base 3 of 7 minus 3 log base 3 of 7. Okay. Now I want to get x on one side. So how am I going to do that? Well, I guess you got to pick one side. Personally, I think it's easier to move the x's to the left-hand side and everything else to the right-hand side. So that term's going to come over here, and this one is going to go over here. When something changes sides, help me out, it changes signs. Yes, thank you.
I'm slightly confused about one thing. So when you did x log base 3 of 7 minus, wouldn't the minus be dividing something, or am I not thinking about it right?
No, you're thinking of the quotient rule for logs.
Yeah.
It doesn't apply here because I'm not taking the log of a quotient.
Oh,
So this is going to be 7x minus x log base 3 of 7 equals -1 minus 3 log base 3 of 7. This -1 and this -3 are not like terms. You can't combine them because that 3 is multiplying the log term. So they're not like terms, don't combine them in any way. Here's the second trick in doing these things. And that is to factor out the x on the left-hand side. So right here, factor out the x. So that's going to be x times 7 minus log base 3 of 7 equals negative 1 minus 3 log base 3 of 7. And last but not least, if x is being multiplied by something, what's the opposite of multiplying? Dividing. So you're going to get negative 1 minus 3 log base 3 of 7 divided by 7 minus log base 3 of 7. That is your answer. Yay. So a lot with that one. You could also do it with log base 10 on both sides or log base e. The problem with log base 10 is that, yeah, you won't get this nice cancellation here. Everything here is going to have a log base 10 term. It's going to be a little bit messy. This, however, requires you be able to work with log base 3. Now, I have shown you how to do that kind of stuff on your calculator. Remember, if you hit the math key and then alpha A, that's going to take you to a place where you can calculate log of any particular base. So real quick here, math, and then alpha A, that gives you log base 3 of, for instance, 7. So it should be someplace between 1 and 2. Perfect. Okay, let me keep going. Ln of the ln of e to the 100. So let me just write that down here. Ln of the ln of e to the 100. Okay, this is a nice problem in a couple ways. There's a couple rules we got to apply, but the first thing to see here is that this term right up here in pink is an exponent. And so I can take that out in front of my logarithm. So that's going to be, let's see, I want to use this one. Ln of e to the 100 times the ln of e. Now, you're not going to see textbooks write this, but I'll write it. So recall, ln of e can be written as log of what base? Log base e of e. So what's log base e of e? It's 1. So e to the 100. So this is just going to be ln of e to the 100. Now, let me rewrite this one last time. Remind me, ln, what does it stand for? Log of what base? So it's log base e of e to the 100. Well, let's remind ourselves of one other thing here. And that's this. This is one of your inverse properties of logs. I've got the whole list of log properties in a little file on D2L. Log base b of b to the x. Remember what that one was? It's just x. This is exactly what we have here. These bases match each other, so all you get is 100. But this is a really good property to know and to have memorized. Write it on the top of your test right when you get your test. All right, let's move on and do another one. Log of x to the 5th over y z to the 6th. Now, there was a base written here. I'm not gonna write the base because it's just gonna slow me down. You have to start with the quotient rule. This is log of the numerator minus log of the denominator. I can use the power rule here, so that's 5 log of x, but I can't use the power rule here. Instead, what rule do I have to use next? Product rule. So that's log of y plus log of z to the 6th. But I've made a mistake here.
6 log.
If you're not using parentheses, then negative has to distribute itself to both terms. So either with parentheses or without parentheses, it should look like log of y minus log of z to the 6th. That 6 can come out in front. So let me just cheat here. And I won't. 5 log of x minus log of y minus 6 log of z. You want to keep going in these until the quotient rule, the product rule, none of those still apply. Okay. Got a couple more here. This one's a nice one. Yes.
Could you, if you just left it with the parenthesis around it, is that fine?
If you left it with a parenthesis around it, on that last one, it's fine as long as you use the power rule. So if you have, if you bring that 6 out here and write as log of y plus 6 log of z and have the parentheses, that's fine. No problem about that one at all. This one is one you're going to have to solve on a graphing calculator or Desmos. So what I would suggest here is that we write two different equations. We write y equals 2 to the negative x for one of them, and we also graph y equals x minus 5 for the other one, and see where they intersect. So let's do that in Desmos because it's going to be desperately easy there. So I want to graph 2 to the negative x, y equals 2 raised to the negative x, and y equals x minus 5. And I want to find where these two graphs intersect each other. So let me hit the home button. That kind of zooms out a little bit. And I want to zoom in a little bit here. It looks like they intersect at 5, but they don't quite. If you zoom in enough, you can see that the intersection is a little bit different than 5. So there you go. 5.031 for x would be the solution. All right, it's just where those two cross each other.
Just the x-intercept?
Yeah, I guess it depends on what they're looking for, but the solution in this case would have to be the value of x, because in the original problem there's nothing for y, right? So the only solution would be a solution for x. So, x is 5.0 something. All right, good on that one?
Yes, I didn't actually think it would be that easy.
What's that?
I didn't think it'd be that easy.
I promise not to put easy problems on the exam. Okay.
Okay.
All right, LOL. Let's see. All right, last one. From these here. Let's take a look at this top one. This bottom one here, you would solve it much like we solved here in terms of, you get everything on one side. Basically, the hard part here is that you would have to figure out how these things factored so you get all your points. The numerator is not a bad one. That's x minus 1 times x plus 5. The denominator, 5x and x. And let's see. I'm trying to think what would have to be here. One of them has to be positive, one has to be negative. I was always terrible at factoring these things.
I just did x minus 25 times x.
No, that doesn't sound right. Here's a cheating way to do this in terms of finding out the roots. I'll just type in the denominator, 5x squared minus 23x minus 10. And let's go back to here. And I can see the roots. One of them's at 5, one of them's at negative 0.4. Now negative 0.4, if you need it, you can look at it here, that's negative 2/5. So that tells me my factorization, kind of reverse engineering these things. That's x minus 5 and 5x plus 2. There you go. Once we have that, you got the roots of the numerator and roots of the denominator. Roots of the numerator would be at negative 5 and 1. Roots of the denominator are going to be a 5 and negative 0.4. Now you got to test points in between all of those. Okay? Put this expression in your graphing calculator or Desmos and test points. Let's see. There was 2 last ones that I wanted to do here for you guys. Maybe 3. And I will post these online so that you can check them there. Nobody asked about solving any logarithmic equations. Maybe you're not that far in your homework, so I'm not like getting down on you. But I want to remind you there's 2 methods by which you can solve a logarithmic equation. The first method is if you can write the equations where log of A equals log of B. If you can do that, then you can get rid of the logs. It's A equals B. Now it's not as if you can cancel out the logs right here, because I don't have log of something equals log of something else yet. So don't do it here. But if you use the product rule to combine these, then you've got log of something equals log of something else. Now, I'm fine with you jumping down to this next step. Basically, you get rid of the logs. If you want to earn an extra credit point, you can show the step that actually gets rid of those things. What base is understood to be here with the logs? 10. If you do 10, if you exponentiate each power with the base of 10, or each side with a base of 10, that's 10 to the log base 10 of 3 times x minus 4 equals 10 to the log base 10 of x. These operations are inverses of each other. It's like cubing a cube root. It's going to cancel out that cube root. Likewise, 10 to this power is going to cancel out the log. So you get this. This is optional. You don't have to show that step. You can go from here to here. Unless you're really confident, just go from here to here and solve. Make sure that at the end, you check your answer. That means plugging it back into the original problem. Now, you don't necessarily have to go this far. That is, say, oh, log of 3 plus log of 2. That's really log of 3 times 2, which is the log of 6. What's the minimum you got to do, though? You got to check it to make sure that you don't get a negative inside the logarithms. That's what you got to check for. All right, and if you do, throw it out. It's extraneous. In this case, it actually works. All right. If you got to go, I understand. That's fine. I'll post this. The other method that you can use to solve logarithmic equations is method 2. You're going to use this if you've got the log on one side but not the log on another side. So if that's the case, then you're going to rewrite that as a to the power y equals x. Sydney?
I'm a little confused as to why you put the base 10 twice on that previous problem. Like if you go back,
10.
yeah, like.
Well, I exponentiated. This is 10 to the power of log base 10.
I see, thank you.
All right. So you bring this together as one term, you exponentiate, or you rewrite it using exponentials. That gives you a quadratic equation. Get 0 on one side, solve. And then, like before, you've got to check and make sure that you don't get a 0 or a negative number when you put it in your original solution. In this case of -4, that doesn't work back in the original problem. You gotta throw that one out. So bummer on that one. But notice that you don't have logs over here. You can't cancel out the log on the left-hand side because there's no log on the right-hand side. So that's when you gotta use method 2. Last one, and I'll make this quick. Suppose you want to find the roots of this polynomial. Maybe I want it completely factored. I've got that one graphed, and there's something about the graph that you should know. Where is it? Here? No. This one? No. All right. I didn't have that one graphed. Where is it? I swore I had that one graphed. All right. Let me just graph it here then. So it's, I'm going to kind of cheat here a little bit. Y equals x minus 1 cubed x squared plus 16. Okay, so here's the graph of this problem. You're asked to find the roots and factor it. Find all the roots. Here's the problem. When you look at the graph, you see something like this. You're like, all I see is one root. But is that all the information you're getting out of this? Think back to what we did before the last test. What's the multiplicity of that root? That's a wiggle, so it has to be at least multiplicity 3, right? So that means x equal 1 is a root 3 times. And this is what you're going to have to do on the test sometimes, is you're going to have to divide that out. X equal 1 is a root. I run through synthetic division. Now I've got a reduced polynomial. This is now a 4th degree polynomial. X equals 1 is still a root of that. So I divide it out again, and I divide it out a 3rd time. So I've divided it out 3 times, and I come down to here. I'm left with this, 1 plus 0, and then a 4. Notice that the remainder was 0, so it worked out evenly. But this is a polynomial. It's x squared plus 4. So what that's telling me is that x equal 1 is a root of multiplicity 3. I can write that as x minus 1 to the 3rd times x squared plus 4. Wow. So after a lot of work, you got all that factored. This times this equals 0 means either this is 0, we know where that's true, or this is 0. And that's true when x equals plus or minus 2i. And so it'll factor like this, x minus 2i and x plus 2i. And that's pretty much all I could ask on that one. So, all right. Realize I went over a little bit, but I hope that helps out. Comments or questions? Study hard. See ya.